Okay, so we use it literally every single day, right? But if I ask you to explain how the internet really works, could you? Don't worry if the answer is no, because in just the next few minutes, you're going to be in like the top 10% of people who actually understand what's going on under the hood. Ready? Let's dive in and unravel this supposed magic. All right, first things first, we've got to bust a massive myth. You hear it all the time, right? The cloud. It makes you picture your data just floating around up there in some kind of digital mist. But as this great quote from Aaron Titus puts it, the internet is not a bubble cloud, the internet is a wire. And that's the key takeaway. It's a real physical thing. So let's start right there. Let's unplug that whole myth and take a look at the actual physical wires that make our entire digital world possible. So on one hand, you've got this myth of the magical fuzzy cloud, but the reality, it's way more, well, concrete. We are literally talking about a massive global web of physical cables. Over 1 million kilometers of fiber optics and copper wires buried under our streets, stretched across the vast ocean floors, all just connecting computers together. And that's the thing to remember. The internet isn't one single entity. It's a network of networks. Okay, so that's the huge global picture. But how does your computer, right there on your desk, actually connect to this massive web of wires? Let's zoom way in and build your very first network from the ground up. You know, it all starts super simple. Just two computers linked together with a single cable. That's a network. Now, what if you want to connect more computers, say in an office? You use something called a switch. Think of it like a local traffic cop, just for your internal network. But the real magic, the piece that changes everything, is the router. The router is the gateway. It connects your entire local network to all those other networks out there in the world. It's basically your personal on-ramp to the internet. All right, so you're connected, you've got your on-ramp, but how in the world does your request for, say, a cat video travel across the globe and come back in milliseconds? It's incredible, right? Let's follow a single piece of your data on its great packet journey. Okay, so the very first thing you need to get is this. Nothing gets sent over the internet in one big chunk. That photo, that email, that video file, it gets shattered into thousands of tiny little pieces of data. And those pieces are called packets. They're basically the Lego bricks of everything you do online. So how do all these tiny little Lego bricks know where to go? Well, think of each packet like a piece of candy. It's wrapped in several layers. Each layer has instructions on it, telling it where to go next on its journey to its final destination. And remember those routers we talked about? Well, they're basically the post offices of the internet. Each router gets a packet, unwraps one layer of that candy wrapper, reads the address for the next hop, and then sends it on its way, one step closer to where it needs to go. It's wild to think about, but a single click from you might send a packet hopping through 10, maybe even 15 of these router post offices to get across the world. Okay, hold on. With billions and billions of devices connected to the internet, how does any packet know the specific address to go to? I mean, that's a lot of mailboxes. This brings us to what is honestly one of the most brilliant solutions on the internet, a massive global phone book. See, every single device on the internet, your phone, your laptop, the server hosting a website, has a unique IP address. It's that long string of numbers you've probably seen before. That's how computers find each other. But let's be real, we humans are terrible at remembering long strings of numbers. That's why we use easy, memorable domain names like google.com. So the big question is, how does the internet translate the words we type into the numbers it actually needs? Well, that's the job of something called the Domain Name System, or DNS for short. It's pretty simple, really. When you type google.com into your browser, your computer basically shouts out to a DNS server, hey, what's the number for google.com? The DNS server, that giant phone book, looks it up and replies with the IP address, like 142.250.190.78. And only then does your computer know the right number to call to connect to Google's server. It's this invisible but absolutely essential translator that makes the entire web user-friendly. Okay, so we've got our packets, they're broken up, they're addressed, and they're being zapped across the globe. But think about it. As they're hopping between all these different routers, all these different post offices, is the information inside them actually safe? I mean, could someone just listen in? This is exactly why the difference between HTTP and HTTPS is so important. Think of HTTP as sending a postcard. It's totally open. Anyone who handles it along the way, any of those routers, can read the entire message.
But with HTTPS, and that S stands for secure, it's like sending your message in a locked metal briefcase. The data is encrypted, meaning it's all scrambled up into a secret code that only you and the server you're talking to have the key to unlock. And that little padlock icon you see in your browser, that's your signal that you're using the secure, locked briefcase. It's a huge deal for things like logins and credit card info.
So that's a whirlwind tour of how the internet works right now. But here's the thing, this network never ever stands still. It's constantly changing, constantly evolving. So to wrap things up, let's just take a quick peek at what's coming next.
I mean, you've got technologies like 5G delivering absolutely mind-blowing speeds, and the Internet of Things, or IoT, connecting everything from your smart thermostat to your car. And on top of that, you have AI and something called edge computing, which are totally changing where our data gets processed, making everything faster and smarter. The Internet of Tomorrow isn't just something we're going to log into, it's going to be completely woven into the fabric of our physical world.
So that brings us to the end. It's amazing when you think about it. We've gone from a simple wire connecting two computers to a global network that powers pretty much our entire society. It started by connecting machines, and then it connected people. So the real question we're left with is, what will it connect next?